slot. So our first speaker is Orchen, who's been diligently working in Python for the last 5 years and works for Orca Security. He's going to be telling you about raising better errors with exception groups. So the floor is yours. Thank you.
Hey guys, I'm super nervous. So this is my talk, exception groups and why we need them. I'm going to tell you about a new feature in Python 3.11 that's going to come out in October, and it's called exception groups. A little bit about me. Like he said, my name is Orchen. I come from Israel. I work at Orca Security, and I've been doing Python since the military days, 6 years ago. And then I continue to do it in the next 6 years in my last 3 jobs. And the weird thing about me is that I love exceptions. Now, that might be weird to you because you link exceptions immediately to the problems that you had. Exceptions are a tool, essentially, that tells you when a problem has happened. And it lets you both handle that problem and debug it more easily. So other languages might not have the robustness that Python has when it comes to exceptions. Python actually gives you a lot of information when it raises an exception. As you can see here, you can see the type of the exception, you can see the traceback and which line it happened, you can see the message of the exception, and you can even see the local variables in each frame of the stack where it was raised from. So you can even access that Europython variable when you raise an exception that has nothing to do with it. So it gives you a lot of information that you can use. So what do exception groups add to that equation, right? Why do we need to group these exceptions? Why is one not enough? Let's see the PEP for a second and what it says about exception groups. So as you can see here, it tells you that exception groups allow us to raise and handle multiple unrelated exceptions simultaneously. You can see a little bit here how they're raised and how they're handled with this except star. These are basically the 2 main additions to the Python language, the exception group and the except star. And we're going to see how they interact exactly. All right, so let's dig into it. First of all, let's see how we can create an exception group. So you can see here that we create an exception group that we need to pass it 2 parameters, right? The first one is the error message, and the second one is a list of exceptions that we will raise. Okay. You can see that we can even pass exception groups as part of these, right? As part of the list of exceptions. That is because exception groups themselves are an exception. They're an instance of exception, which means you can do anything that you can do with a regular exception with them. You can raise them, you can get their message, you can print their trace stack, and you have some additional things too. You can see the list of exceptions. It returns the tuple of exceptions. And it has some additional methods. For example, this subgroup method will return to you all of the different value errors that were in the exception group or in nested exception groups as well. Okay. This is not supposed to happen. Okay. Now we have exception groups, but I'm going to show you why it's not enough. Okay. If we will say, okay, we have some case where we need multiple exceptions. Okay, let's assume so. For example, you have this classic function, smells on Tuesday. And if it's Tuesday, it will raise an exception group, and otherwise it will raise a normal exception. Now, when I handle exceptions, I need to know every time, is it an exception group or is it a regular exception? That adds this is instance to my code everywhere. And it's a bit messy. That's not what we really want to do. We don't want our code to look like that. what do? We have except star. Except star, we look inside that exception group, and it will extract part of the exceptions that match on what we give it. So this except star memory arrow will only catch the memory errors out of the group. The rest of them will continue to be raised, okay? But since we have two except star clauses here, both the except star memory error and the except star connection error, they will all be caught right here. And as you can see, we actually enter both of the clauses. This is different from the regular except, where you can only enter one of them. Here you can enter multiple of them. And that means a couple of things. First of all, you can't return or break or continue while you're inside an except star clause, because that might hurt the other exceptions that are being raised. So there's a limitation on that. And let's see what's more. When we raise a regular exception, it will also be caught in except star clauses. There is one difference, though, than a regular except, and it is that this exception will be actually inserted into an exception group. As you can see, except star actually returns an exception group with all the exceptions that matched, right? So here, you will still get an exception group even though you raise the normal exception. Now you don't need to check in except star clauses if it's a regular one or if it's a group. It's always a group. Okay. Let's see some use cases. I mean, it's nice, sure, exceptions in a group, but I guess you've all been coding for some time and you never used it. And why do you need it, actually? Let's see some use cases. The first one is retries. Do you have some retries in your code? Who here has retries in their code? Okay, that's a lot of people. Right here we're going to see an example. Let's assume you have some retry that is from a library. Okay, so you can't actually touch the exception handling yourself. And it wants to get some URL. It gets the number of retries that it wants to do. And then it will try to get that URL. Every time that it fails, it tries again until it gets to the third time in this case. And then it will raise the last exception. Okay? So what is the problem here? The problem is that we don't see the former exceptions. So we won't be able to handle them in case we want to. For example, here, let's assume that it returns us authorization error twice and then too many requests. Okay. I'm not sure why it would do that, but okay. Now, if we try to get that URL and then catch authorization error, we wouldn't catch it, right? We wouldn't know that we need to log in afterwards. But let's see illustration. Let's see how we can use exception groups to improve that. So we will now have a list of exceptions. And each time that we do get an exception, we will add it to that list. And eventually, we're going to raise an exception group with all of these exceptions. Outside, we have changed to except star. And then it will actually catch that authorization error when it happens. It will actually catch both of them, put them in a group, and do the login. OK. The too many requests will continue to be raised. It's still an error that we need to catch. But it does the login like we wanted it to. The second use case is a bit more complicated. It has to do with async I/O. And it's actually relevant in threads, in subprocesses, but I've gone with async I/O in my example. Who here knows async I/O just a little bit? OK, that's pretty good. I'm just going to go 1 minute about what it is and how it works. Async I/O lets you run code concurrently. So it lets you run multiple functions at the same time. Basically, you have coroutines. Coroutines are defined with that async keyword before the def. And when coroutines are called, they are not immediately executed. When they are called, they return an object. And we can later await on that object for them to be called. Now, we can, inside these coroutines, also await for some blocking operations, for example. And in the meantime, other coroutines will be executed. Okay? So in this example, we create two coroutines. We print that we're running both of them. They're not immediately executed. And then we await on async.io gather. Async.io gather is a function that lets you await on multiple coroutines, basically. So we pass it both coroutines, and then they will both be run. OK. So let's see some example with async.io, and let's see what is the problem that we currently have when we run this code. So we create coroutines. We then create tasks out of those coroutines. Tasks are like coroutines, but they're higher level objects. So we have an easier interface for interacting with them. For example, we have that exception method that returns us an exception if one occurred. Now, after that, we're going to use async.io wait to wait on those tasks. It's kind of like async.io gather, so we can wait on multiple tasks. But it returns to us two tuples. The first one are the done tasks, and the second one are the pending tasks. OK, the ones that didn't complete yet. So the coroutines themselves, what they're going to do is they're going to select one of these errors based on the I that you give them, and then raise it eventually. Now, assume we want to check if any exceptions happen and then handle all of these exceptions. So we now need to iterate over the tasks. We need to check if they had an exception. If they did, we will raise that exception. And only otherwise will we handle the task. Now, it's a lot of code. I mean, all we want to do is just handle some exceptions, right? Also, it's pretty indented, and that's kind of ugly. And also, we have to raise them ourselves, right? We need to get the exception object and then do the raise ourselves. I don't want to do that. I want Python or that function that I'm calling async.io wait or something like that to do that for me, right? But it gets actually even worse. Let's assume that you want to stop after the first exception. You would probably want to do that because you don't want to waste resources that the coroutines that are still running are wasting. What's going to happen is that your pending tasks are still running, OK? So after you return from the exception that you got, you now need to go over the pending tasks and cancel them. After you cancel them, even that's not enough, because you then need to do async.io wait for them to run for a little bit. Now, we want them to run for a little bit because they might have some finally clause. That finally clause will only be called after that async.io wait is called. Okay? I actually didn't know that, and I had to fix some bug in my code when I first learned about it for this lecture. So that's all of the code that you need just to handle the exceptions. But I just want to handle the fun parts, right? I want to only see that happy flow, hopefully. OK, so let's see how we can do that. Let's implement another version of wait ourselves that uses exception groups. OK, so as you can see, I will now await on this wait instead of async.io.wait. And in this wait, I basically implemented what I implemented before. And I can use anywhere for my code, I can use this wait function. It will go over the exceptions, and it will raise them as an exception group this time. This is the key difference here. Then this exception group can be caught with except star, like we've seen before, and then handled as we see fit. Now, there is one issue here that I have with this code, and it's that I don't want to implement wait. I want something else to do it for me. I want it to be some part of a library, preferably the standard library. Well, we're in luck because the Python gods have been good to us, and we have exception groups, task groups, sorry. So task groups are basically the new way to create and run tasks. What they do is we use a context manager, async with the async.io task group, and then we create tasks on the task group, and when we exit the code block, all of the task group will run. After it runs, if there are any exceptions, it will raise an exception group for us. So eventually, in the main function, I only need to call the run task group and handle the exceptions. And the happy flow can all stay inside the run task group method. So that's much cleaner than the earlier iterations that we've seen of it. Okay, so we got to the third and final example, errors in context managers. And let's see the problem. So we have the main function. In that main function, there is a context manager that we use, a time reporter. It's going to report the time that this code block has taken. And what it's going to do inside, that's the business logic that we have. And we're going to divide 1 by 0. I'm really interested in the result. And outside, if I do have a zero division error, like I should have, I will print a business logic error. OK. There is only one problem here, and it's the time reporter itself, the context manager, also raises an exception when it exits. When it exits, it sends a report. And this report doesn't have the connection to the log server or whatever it wants to report, and it raises a connection error. So what will happen is that we don't actually raise the zero division error. We won't catch it, because what we can raise is the connection error. You can see that it is chained here. There is that zero division error in the message, in the traceback, but you will actually get a connection error eventually. So let's see how we solve it with exception groups. Now the exit function will catch any exception that it gets. And if it does get exceptions, it will raise a group with these exceptions, which will contain the original error that we had and the new error. And now we can actually catch both exceptions or part of them. So here I only catch the zero division error. And eventually I'm printing out business logic error like I wanted to in the first place. OK? So the other error, of course, is still raised, but that's fine by us because we didn't catch it. Any questions?
Okay, guys, don't need to be shy. Any questions online? Yeah, so we've got one in the room. Go ahead.
Hello.
Hi, thank you for the introduction. And I have a question. So you mentioned early, and we also saw that in the last example, that if you have an except star, you will basically have a fall through, and all the other exceptions you're not catching will be re-raised, right? Like you are only catching the zero division error, and then you are letting the exception group.
The rest of the exception group will be continue to be raised, yeah.
But okay, in this example maybe it doesn't apply, but in the early example you had, we are basically switching from a regular exception to a group, and then we would not basically catch the other errors.
In which previous example was it?
Yeah, I think it was
Async IO or?
No, before that, early slides. So you had like basically two except star. And, sorry for the context.
This one.
Yes, this one. And so basically what would happen here if we have like another type of exception that we don't see, but we don't want to bubble it up elsewhere, right?
You don't want to propagate the rest of it? So you can use except star exception, or even a base exception, and then every other part of the exception group will go to that last exception.
Right. Can you also do an except star on exception group to catch the overall group?
Except star and exception group, I think it's disallowed because it's kind of confusing. Yeah, sure. But you can use, and you can't use except with except star. Yeah, you can't combine the two in the same clause because it's also pretty confusing.
So basically the way to make sure you will catch everything here would be to use a basic
except star exception.
Okay.
Okay. Thank you.
Right, let me just check. Are there any questions online?
Okay.
No?
Hi, it's actually first time I see this except star and exception groups, and I wonder whether it's the same effect as sort of with async code now, that wherever you have async code in the library, it sort of poisons everything up, and I have a feeling, especially the last slide that you showed, now you actually have to have the except star to handle this exception group that, let's say, this library code introduced. So is this the life for us now? Do we have to always expect libraries to give exception groups to us? Like, do we have to change our whole thing and always put stars everywhere? Or like, how do you feel about this?
Great question. So basically, you don't have to use exception groups. As long as you don't have exception groups, you don't need to use except star.
But
if there is a library that raises an exception group, you can, if you want, just use the regular except with except exception group, because exception group is a type of an exception, and you don't have even to use except star. Does that answer your question?
No. Let's say that you are a sloppy Python engineer and you just do except exception, not exception group. And what if the library code actually throws an exception group? What happens then? Like exactly what you have at the top. You do just normal except exception, right? Mm-hmm. But let's say that the main is actually a library code that throws an exception group. What will happen?
So the except exception will catch an exception group.
Okay.
Okay?
Thank you.
Thank you.
All right, just a quick one. Do you think it makes sense to subclass the exception group to like define your own, or is it more intended to be like that's
definitely, yeah. You can subclass exception group the same you would exception, and maybe you would want to do an exception group of a certain type, and then you'd want to catch that specifically. For example, a value error exception group, and then you can do a regular except of value error, and maybe you would add some attributes to value error. You could definitely do that.
Right, so for all intents and purposes, you can just use them as you would use exceptions, except they have a place where you can just
where you can go only to a part of the exception group, yeah. Or yeah.
Right, thank you.
Thank you.
Thank you for the talk. Because this is going to require Python 3.11 specific syntax, the except star, do you see that as a hindrance for library maintainers to implement it because it means their codes only work with 3.11 forward?
I'm not sure I understand. I think it's an hindrance because by the time that companies are going to start using 3.11, 3.14 is already going to be out. That's the main thing. But what exactly did you ask?
So say I'm writing requests, and you had a great example with retries there, where instead of bubbling up the last exception, you can bubble up all of them with an except group. If I'm the maintainer of requests and I want to implement that for my retry function, am I going to be unable to do that until I drop support from Python 3.10, Python 3.9, Python 3.8 going backwards?
Yeah.
Okay.
Basically, yeah.
Thank you.
Thanks.
Okay, any other questions online? In the room, go ahead.
Related to support, do you know if, or was it part of the PEP, that exception group, the type of exception, will be backported and will be available from futures, for instance?
It might be, I'm not sure, actually.
Because there is nothing against using that in common versions, right? It's just like a collection of exceptions.
I guess it's possible, but not sure.
Okay.
Thank you.
Okay. We're still a teeny bit ahead of schedule, so if there's any last question, either online or in the room, feel free. If not, let's thank Or again for a fantastic presentation. There was certainly no need to be nervous.
Thanks.